Hi guys, welcome back to my YouTube channel, Let's Crack Real Math. My name is Viraaj, and in today's video we'll be having a look at how to solve modulus inequalities. So without any other delay, let us begin. So to begin with, what exactly is a modulus? A modulus is when you see anything that has these two straight lines with an expression inside of it. Let's say, for example, we have ax inside it. What the modulus signifies is whatever that's inside is always going to be positive. The final is always going to be positive. So if I have ax, the final answer of this is ax. If I have something like this, minus of the ax, then the final answer is also going to be ax. So the modulus always turns the negative into a positive and keeps the positive as the positive. In terms of graphical representation, the modulus is always a reflection in the x-axis. So if I have something like, say, this is my plane, and if I have a graph, or a curve rather, straight line curve, going from here to here, the modulus of this would be everything in the positive y-axis, hence a reflection in the x-axis. So if I were to now reflect this, I would have something like this, going up. So the modulus turns out reflects it in the x-axis, so that we only have positive values of y, and that's basically the function of a modulus. Now, a modulus inequality, as we know, an inequality is whenever you have something in the form, let's say 2x plus 4 less than 3. We know that this is not an equation because it does not have an equal to sign. It has an inequality, that is in this case less than. That means that for whatever value of x, there are only, or rather for whatever value of this equation or expression rather, there are only a certain value of x that can agree to it or fulfill it. Not every value of x would give you or obey this particular expression. Now, another thing to note in modulus equation is the sign that you're using in the equation. If you're using less than or equal to, whatever your final answer, but in this case, in this video's case, answers, because we'll be having multiple answers, you always group your answer together, your final answer, the format you write it in. So let's say I get as my values, one of my values is 1 and the other value is 6, and my original, or the equation that I derived this from, was using less than. So if I was to now write my final answer, I would write in the format of 1 less than x less than 6, and this is how my final answer would look like. If I was using less than or equal to, then I would just change this with less than or equal to and less than or equal to. Of course, I will explain it further in the video how you should not always leave it like this, how you should also check the values, but that will be explained in a moment. And on the other hand, if you use greater than or equal to, then you do not group your answers like you did over here. You write them down separately. So again, if we use 1 and 6, I will now write my answer as x is greater than 6 and x is less than 1. So you can see that these two are the different types or ways you can write down your answer. Again, I'll emphasize again on how you should check your final value and then input the final format of your answer. Again, this is a topic that is much better understood when you've done examples and you've really practiced a lot of questions. So let's go right into our first example. Now for this video, I will be solving these inequalities in two different methods. The first method would be squaring both sides, while the other method would be deriving two separate equations before getting a final answer. Now, it would be advisable for you to check out your exam board syllabus and see which method they mark, because not all the time both methods, maybe some syllabus boards only prefer one method over the other, or vice versa. And of course you can have your personal preferences or which method suits you, but it's my duty to show you both of them, hence I'll do that. But please make sure you use the right one at the right place and certainly at the right time. So the first example, I have modulus, let's just write that modulus again, 2x plus 3 greater than 3 into x plus 2. So the first method, which is squaring both sides, I'll just rewrite this as brackets. So 2x plus 3 greater than 3 into x plus 2. And as I said, squaring both sides, self-explanatory, we square both sides. So we square this, and we square all of this. Not just x plus 2, but everything. So we have 2x plus 3 all squared greater than 3 squared into x plus 2 all squared. Now we can go ahead and expand this. We have 4x squared plus 12x plus 9 greater than 9 into x squared plus 4x plus 4. And this can be simplified further. We have 4x squared plus 12x plus 9 greater than 9x squared plus 36x plus 36. If you're not comfortable with the expansion of brackets, then you can always head over to my previous video on expansion of single, double and triple brackets. Now take everything to the left hand side. We have 4x squared minus 9x squared, that's minus 5x squared. 12x minus 36, that's minus 24x. And 9 minus 36 gives me minus 27, greater than 0. Now from here, always advisable to have your coefficient of x squared positive, so times the equation by minus 1, or you could say take everything to the right hand side, same thing. We have 5x squared plus 24x plus 27 is less than 0. Note how our signs changed, because whenever you times by minus 1, if you times the equation by minus 1 or take everything from one side to the other side, then your sign changes. So we have 5x squared plus 24x plus 27 less than 0. So now we go ahead and do our factorization. We have 5x squared plus 9x plus 15x plus 27 less than 0. X is common, so we have x into 5x plus 9, and then we have plus 3 into 5x plus 9 less than 0. And going ahead, we have x plus 3 into 5x plus 9 less than 0. So I'm not going to give my final answer here. I'm just going to say we are our critical values. We know our critical values over here is minus 3 and minus 9 over 5, because if you were to eventually equate these two to 0, these are the two values you will get. Now if we, as I said, we look at the sign that we use. Now this can be a bit complicated because we started off initially with a greater than sign, but our final answer was derived via a less than sign. So which one do we use? The answer is we use the one that is the more recent one, and in this case the less than. So we write our answer, as I said, with the smaller one first, minus 3 less than x less than minus 9 over 5. We write the answers together because we use the less than sign, and that is the answer for that one. Now always advisable, always 100%, to check your values. Sometimes questions can trick you by doing this little deed, you could say. You might think that this is the final answer and you've done and you've gotten your marks, but actually one of them might be wrong. And to make sure that you get your full marks, you should always check 3 values. So in this case, 1 that's in between -3 and -9/5, 1 that's greater than -9/5, and 1 that's less than -3. And we put these values back into our original equation, and according to our answer, the only value that should stay true to the equation is the one that's between -3 and -9/5. So let's try -5 as a value. As we know, -5 is less than -3. That indicates that if we are to put -5 into our original equation, the equation is not meant to hold, it's not meant to take place. Let's check it. If we put -5 over here, we have 2 into -5, we have -10, plus 3, that's -7, and since it's modulus, everything becomes to positive, so -7 turns into +7. And if we put it over here, we have -5 plus 2, that's -3, and -3 becomes +3, so we have 3, and then times it by this 3, we have 9. And is 7 greater than 9? No, it's not. Hence, that means -5 cannot take place, but our answer so far is still correct because it indicates that x value is greater than -3 but less than -9/5. Now let's take a value greater than -9/5. -9/5 is roughly -1.8 if I'm not wrong. So let's go ahead and take 0 because we know 0 is greater than -9/5. So if we take 0, if we go ahead and put 0 over here, we have 2 times 0, that's 0, plus 3, which is 3, so we have 3 over here. And if I put 0 over here, I have 0 plus 2, which is 2 times 3, which is 6. And is 3 greater than 6? No, 3 is not greater than 6. Hence that means 0 cannot hold, and hence this side of the equation is also correct. Because it says it has to be less than -9/5, and 0 is greater than -9/5, so it is not meant to hold. Now let's take a value between -3 and -9/5, and that should be -2. So if we take and put -2 into our equation here, if I put -2 over here, I have 2 times -2, that's -4, plus 3 is -1, this becomes 1. Again, modulus sends everything that's negative to positive, and if I put -2 over here, I have -2 plus 2, which is 0, times 3 is also 0, negative 0 positive 0 remains 0, and is 1 greater than 0? Yes, 1 is greater than 0. That means that this answer is correct, and hence we can leave our final answer in this format. I know it may seem a bit time wasting to check your values at the end like this, but once you get used to it, you can do it really quickly in your head mentally or using your calculator, and it's really a safe way of confirming your answer. Now the other method that you can use to solve this question is a method I don't usually use. I prefer squaring both sides as it is more accepted in exam boards. However, this method is also not wrong, and you can very much use it over the squaring of both sides. So in this case, what you do is you ignore the modulus. You say you derive two equations. You get 2x plus 3, use equals to 3 into x plus 2. That's your first equation. And then you use another equation, and you do 2x plus 3, but equal to the negative of 3 into x plus 2. And then you solve these two separately for x, obviously. So we have 2x plus 3 equals to 3x plus 6. 3x goes over here, we have minus x equals to 3, we have x is equal to 3. And going the other way, we have 2x plus 3 equals to minus of 3x plus 6. We have 2x plus 3 equals to minus 3x minus 6. We have 5x equals to minus 9. we have x is equal to minus 9 over 5. Now this is not the final answer, obviously. As you can see, the critical values 3 and minus 9 over 5 is the same as we had gotten from here. But in this example, in this scenario, for example, the question originally started with greater than. We know that it turned when we did squaring both sides, it eventually converted into a less than sign. So if you're the type of person that's going with method 2, you might just give your answer in the form x is this minus 3, sorry, my bad. You might just say the answer is x is greater than minus 9 over 5 and x is less than minus 3. And that is wrong, because this is not how your answer is meant to be. Your answer is meant to be grouped together. And that is one significant drawback of this method, is that you cannot know just based solely on the equation or the question what sign and how exactly to format your answer. So in this case, again, we check with different values. So we can create a small number line. We can have, let's say, minus 3 over here. Let's say we have minus 9 over 5 over here. This is our number line. Not very straight, but so again, we take a value that's greater than minus 9 over 5, we take a value that's less than minus 3, and we take a value that's in the middle. And we did that in the method 1, and we found out that these guys do not work, do not suffice the question. It's only the values over here. And if that's the only value that suffices, then we know that we can say our answer is in the form minus 3 less than x less than minus 9 over 5. So as you can see, that's the other method. I'll just repeat it. The main disadvantage of it is knowing which signs to use. However, one might say that the time you spend checking over here is the same amount of time you spend checking at the final over here. So the second method is a slightly quicker way, but the first method I can say is 100% accurate. Really, it might take a bit more, but if your algebra is strong, if you can quickly expand and collect like terms and factorize with ease, then first method should be the way you should stick. Now on to the next example. We have 2x minus 3, modulus of course of 2x minus 3, greater than modulus of 4, greater than 4 modulus x plus 1. So let's start with the second method this time. Let's go with the second method. I have, of course, I'll make two equations. I have 2x minus 3 equals to 4 into x plus 1. And my other equation will be 2x minus 3 equals to minus of 4 into x plus 1. So solving the two of them, I have 2x minus 3 equals to 4x plus 4. I have minus 2x equals to 7. I have x equals to minus 7 over 2. And from here, I have 2x minus 3 equals to minus of 4x plus 4. I have 2x minus 3 equals to minus 4x minus 4. I have 6x equals to minus 1. I have x is equal to minus 1 over 6. Now these are my two critical values, and although the question says greater than, we cannot just assume it, so we're going to do our number line technique again. Minus 7 over 2. And then let's say we have minus 1 over 6 here. Number line continues up and down. So we take any value that's greater than minus 1 over 6, we take a value less than minus 7 over 2, and we take a value in between them. So let's take a value greater than minus 1 over 6, let's say 0. So if I put 0 over here, I have 2 times 0, which is 0, minus 3 eventually becomes positive 3. And if I put 0 here, I have 0 plus 1, which is 1, times 4, which is 4. And is 3 greater than 4? No, 3 is not greater than 4, hence anything above minus 1 over 6 does not work. Let's go below minus 7 over 2. Let's take minus 5. So taking minus 5, if I put minus 5 over here, I have 2 times minus 5, that's minus 10, minus 3 becomes 13, positive 13, minus 5 plus 1 becomes minus 4, which eventually becomes plus 4 times 4 is 16. And is 13 greater than 16? Nope, it's not. So this does not suffice as well. Anything in between minus 7 over 2 and minus 1 over 6, let's try minus 1. So if I put minus 1 over here, I have 2 times minus 1, that's minus 2, minus 3 is minus 5, becomes positive 5, and then I have minus 1 plus 1 is 0, times 4 is also 0, and is 5 greater than 0? Yes, 5 is greater than 0. That means it's only in between the two values that the equation suffices. So we write our final answer in the form minus 7 over 2 less than x less than minus 1 over 6. And hence that is the final answer for that one. Again, you can see the question had greater than, but our answer was formatted in the way that it's less than. And this can now be confirmed with our second method, that is if we square both sides. So if we go ahead and do that real quick, I have 2x minus 3 all squared greater than 4 squared into x plus 1 all squared. Expanding brackets, I have 4x squared minus 12x plus 9 greater than 16 into x squared plus 2x plus 1. I have 4x squared minus 12x plus 9 greater than 16x squared plus 32x plus 16. Collecting our like terms, we have minus 12x squared minus 44x plus 7 greater than 0. Going ahead with our factorization, or rather first of all take everything to the right hand side. Always work with a positive coefficient of x squared, so this becomes 12x squared plus 44x okay, my bad, sorry guys, this meant to be minus 7, and then this becomes plus 7 greater than 0 less than 0, because we took everything to the other side, or times it by minus 1, same way of saying it. Factorizing this, we have 12x squared plus 42x plus 2x plus 7 less than 0. This becomes 6x is common, so we can say 6x into 2x plus 7 into plus 1 into 2x plus 7 less than 0. We have 6x plus 1 and 2x plus 7 less than 0. Our critical values in this case is also the same, minus 1 over 6 and minus 7 over 2. And our answer was in the form of less than 0 in that format, because as you can see the signs changed from here to here, the sign changed, hence it was in the form of less than 0. Another tip with the two methods, you can always use the second method. In the second method I mean the method with the two different linear equations, that's this method over here and here. You can always use this to confirm your critical values if you are the type of person that wants to square both sides and you may have doubts over your critical values. You can quickly go over and do this over here, derive two separate equations and solve for x's, and then you can confirm if your critical values are correct, because these type of questions usually go for anywhere between 3 to 5 marks, and bulk of the marks is till the extent you get your critical values. The final format of the answer is usually just a mark. So on to the final example. I have the modulus of 2x minus 1 less than the modulus of less than 3 and the modulus of x plus 1. So let's go ahead and do this. Let's use the first method. Let's use complete squaring both sides rather. So I have 2x minus 1 all squared less than 3 squared into x plus 1 all squared. 2x minus 1 all squared, expanding this, we have 4x squared minus 4x plus 1 less than 9 into x squared plus 2x plus 1. And we now have 4x squared minus 4x plus 1 less than 9x squared plus 18x plus 9. Collecting alike terms, we have minus 5x squared minus 22x minus 8. Yeah, 1 minus 9 is 8 less than 0. Times everything by minus 1, or take everything to the right hand side to work with a positive coefficient of x squared. We will now have 5x squared plus 22x plus 8 is greater than 0. The sign changes. Factorizing this, we have 5x squared plus 20x plus 2x plus 8 is greater than 0. 5x is common, so we can say 5x into x plus 4 plus 2 into x plus 4 is greater than 0. And we now have 5x plus 2 into x plus 4 greater than 0. And my critical values, CB, minus 2 over 5 and minus 4. Now I'm just going to leave it here for now. I don't want to write my final answer yet because I want to confirm it with the second method. So quickly, I could just say my two linear equations that I can derive. I'll have 2x minus 1 equal to 3 into x plus 1, and my other equation would be 2x minus 1 equal to minus of 3 into x plus 1. So solving this, we have 2x minus 1 equals to 3x plus 3. Take 3x to the other side, we have minus x equals to 4. I have x is equal to minus 4. I think that was one of our critical values, yeah. And this other guy over here, we have 2x minus 1 equals to minus 3x minus 3. This guy goes to the other side, we have 5x equals to minus 2. I have x is equal to minus 2 over 5. So the critical values are the same. That means we're on the right track. Now let's just confirm with our number line over here what exactly is the final format. We could say we know that the format is in terms of greater than, but also sometimes when you do have greater than, there can still be a particular value that might not work, so always good to confirm with the number line. Let's say we have somewhere over here we have minus 4, and somewhere over here we have minus 2 over 5. So let's take a value greater than minus 2 over 5. Let's take 0. So 2 into 0 gives me 0, minus 1 is minus 1, becomes plus 1. And 0 plus 1 is 1, times 3 is 3. So is 1 less than 3? Yes, it is. So that means for any value greater than minus 2 over 5, this suffices. Let's take a value less than minus 4. Let's take minus 5. So I put minus 5 here, I have 2 times minus 5, which is minus 10, minus 1 is minus 11, turns into positive 11. Minus 5 plus 1, that's minus 4 turns into positive 4 times 3 is 12. And is 11 less than 12? Yes, it is. So this one also suffices the equation. Now let's take something between minus 4 and minus 2 over 5. Let's take minus 2. So if I take minus 2, 2 times minus 2 gives you minus 4, minus 1 gives you minus 5, this becomes positive 5, and minus 2 plus 1 gives me minus 1, becomes 1, times 3 is 3, and is 5 less than 3? No, it's not. So hence this, anything in between the two does not give me the required answer. Hence, if I am to now write this, the final answer, the format would be x is greater than minus 2 over 5 and x is less than minus 4. That is the final format of this answer, because of course we used the squaring both sides first, then we used the second method with the linear equations just to confirm our critical values, and you can then directly go ahead and check it out with your number line and get your final answer. Sometimes, however, the number line always works, but the squaring of both sides, we know it was a greater than sign here, so we could directly just go from here and go to this answer over here. But a lot of times in exams, on purpose, some questions may trick you. For example, I can't think of an example of head right now, but maybe this answer will not be there, because once we check with our number line, anything below minus 4 would also be cancelled out, so it would only be one range of values that would work, and then we would write our final answer as x is just greater than minus 2 over 5. Mark schemes would say that the final answer, the critical values, both of them should be obtained, but the final answer should be written as x greater than minus 2 over 5 only. So that brings us to the end of this video. Thank you for watching. Hopefully you enjoyed. Please do not forget to perform an LSS, that is like, share and subscribe. Thank you for watching. Have a nice one.